Hello, my name is Anirudh Mohan, and this is my project. I'm going to be talking about bond enthalpies, which is unit 6.7, and how they help us determine the energy changes in chemical reactions. I am in first period AP Chem. Let's get started. Slide 2 Introduction. What is bond enthalpy in the first place? So, a bond enthalpy is the energy required to break one mole of a specific bond in a gaseous molecule. It's measured in kilojoules per mole, or kJ over mole. Bond enthalpy is important because chemical reactions involve breaking old bonds and forming new ones. Breaking bonds requires energy. That is called an endothermic process. Forming bonds releases energy. This is called an exothermic process. By comparing the energy needed to break bonds with the energy released when new bonds form, we can determine whether a reaction absorbs or releases heat. So let's examine the concept behind bond enthalpies. So bond breaking is always endothermic because we have to put in energy to separate atoms. On the other hand, bond formation is always exothermic because energy is released when new bonds are formed. However, just note that bond enthalpies are average values. This is because a bond strength can vary depending on the environment. An example would be that a CH bond in methane could be have a slightly different bond enthalpy than a CH bond in ethane. So now let's look at the bond enthalpy formula on slide 4. So the formula is delta H is equal to the summation of the bond enthalpies of the bonds broken minus the summation of the bond enthalpies of the bonds formed. And note that the backwards E looking figure mean the summation. So to use this formula, use these steps. The first one, list all the bonds being broken and their enthalpies. Step 2, list all the bonds being formed and their enthalpies. 3, subtract the sum of the bonds formed from the sum of the bonds broken. And to remember this equation, use the acronym basketball is my best friend, which represents bonds broken minus bonds formed as the BBMBF lines up. So just keep basketball as my best friend in mind. Now let's move on to steps and processes on slide 5. So the method to tackle bond enthalpy problems are as follows. First, ensure the equation is balanced, and then see what bonds are present in the reaction. Then write down all the bonds that are broken on one side and bonds that are formed on another side of the paper. So clearly separate the two so you don't get them confused. Then write down the sum of the bonds broken enthalpy values together. So sum those up. And do the same for the bonds formed. So you're going to sum all the enthalpy values of the bonds broken and the bonds formed. Then subtract the value of the total enthalpy of the bonds from the bonds broken's total enthalpy. So you're just going to apply that basketball is my best friend, bonds broken minus bonds formed to get your delta H value. Oh yeah, and also please note that the units are in kilojoules for the delta H value. Okay, and then this is the enthalpy table. This would be really helpful if you're not given the enthalpies of the bonds. So you just keep referring back to this. Okay, so now let's do a practice problem. So let's apply what we've learned. So calculate the enthalpy change for this reaction. CH4 plus Cl is an equilibrium reaction with CH3Cl plus HCl. And the bonds enthalpies are given as CH bond is 414 kilojoules per mole. The CCl bond is 328 kilojoules per mole. The HCl bond is 341 kilojoules per mole. And the Cl-Cl bond is 242 kilojoules per mole. We can use this to find the enthalpy change of the reaction, the delta H. How we will do this is by applying the steps we learned earlier. So first, we have to identify what bonds are present in the reaction. So let's consider the bonds broken first, which is on the reactant side. So what do we have? We have a CH4 atom, and what are we going to do with that? We're going to find the bonds that are present in this. So what we can do is draw the Lewis structure for this. So when we draw the Lewis structure for this, what do we get? Here, it's been drawn here. A CH4 molecule has 1, 2, 3, 4 CH bonds. So now we know that there's 4 CH bonds in the reactant, or the bonds broken. So we have 414, and we have 4 of them. So we do 414 times 4. We'll keep that in mind. Then in the other reactant, or the bonds that are broken, is a Cl2. So we just draw the Lewis structure for this as well, and we end up getting ClCl with all of this, and we see that there's one ClCl bond that is being broken in Cl2. So we use the ClCl bonds given right here, which is 242. Then we refer back to the formula. What was the formula? Basketball is my best friend. Bonds broken minus bonds formed. So we're going to take the summation of the bonds broken, which is what? This is the 4 CH bonds, which is 414. We're going to multiply that by 4 since we have 4 CH bonds. And then we're going to add 242 because that's a ClCl bonds enthalpy into that. So what we're going to do is do 414 times 4 and then plus 242. And that should, I believe, be 1898 kilojoules per mole. Now we will consider the bonds being formed, or in this case, the products. So what is that? That is a CH3Cl and the HCl. So first we'll consider the CH3Cl. So let's draw the Lewis structure for this too to figure out what type of bonds and how many of them are there. So when we draw the Lewis structure, we'll get something like this as shown here. So let's identify the bonds in this molecule. There's 1 CH bond, 2 CH bonds, 3 CH bonds, and then we have this 1 CCl bond. So how many do we have? We have 3 CH bonds, then 1 CCl bond. So let's refer back to this. So we have 3 CH bonds, so it's 414. We're gonna multiply that by 3 since we have 3 CH bonds. Then we're adding 1 CCl bond, so it's 328. So we're going to do 414 times 3 plus 328 for the CH3Cl bond. Then for the HCl, which is also a bond that's being formed, we're going to have this as our Lewis structure, which is just one HCl bond. So we'll add that to our bonds formed. So we will add this one HCl bond to what we had earlier. So what we have for the bonds formed is 414 times 3, since there's 3 CH bonds, plus 1 CCl bond, which is 328, plus 1 HCl bond, which is 341. So we'll do 414 times 3 plus 328 plus 341. Because, as I said before, basketball is my best friend. We're summing up the bonds formed. And I believe that should be equal to 1911 kilojoules per mole. Then, what was the formula? Bonds formed minus bonds broken minus bonds formed. Or basketball is my best friend. We have the bonds broken, the sum of the bonds broken, sum of the bonds formed. So all we have to do is subtract them, which is 1898 minus 1911, and that is equal to negative 13 kilojoules. So that is our delta H. That is our that is our enthalpy change, and that should be our answer. There's also some real world applications to this. In fuel combustion, we use bond enthalpies to estimate how much energy is released when burning fuels like gasoline, and in food metabolism, when our bodies break down and form chemical bonds to release energy. So, an example of a bond breaking is the dissolution of NaCl, and an example of a bond forming is when H2 gas and O2 gas form H2O. And here's some reference videos.